Dr. Kritika completed her BE in Electrical and Electronics Engineering and MTech in Power Systems in the year 2000 and 2004 respectively. She is currently working as professor at the EEE department of NIT Trichy and has a total of 20 years of teaching experience. He is with NIT Trichy since the year 2006 and has published 62 international journals on
Recording in progress.
conference publications of international repute. She is a reviewer of many reputed journals. She has guided many UG and PG projects. She has also guided 5 PhDs and 1 MS student by research. She is a senior IEEE member and fellow of the Institution of Engineers. Her areas of interest are power systems, distributed generations, and microgrids and high voltage DC transmission. So the next panelist is Dr. Bala Sri Raghavan, who is the founder and CEO of Datanetics Solutions Incorporation USA, a company specializing in customized software solutions, wearables, web and mobile apps, and Dynamics ERP and CRM Salesforce services. With a strong background in technology and business management, Bala has led Datanetics to become a key player in the customized software technology industry. His leadership is characterized by a commitment to innovation, quality, and customer satisfaction, driving the company's growth and success in a competitive market. Now I will move on to the next panelist, Dr. Sriram Shankar, Assistant Professor, Department of Instrumentation and Control Engineering from National Institute of Technology, Tiruchirappalli. So Dr. Shankar completed his BTech in Instrumentation and Control Engineering from NIT Tiruchirappalli in the year 2010 on the Doctor of Philosophy with the Masters of Science from Indian Institute of Science, Bangalore in the year 2018. He is currently working as a assistant professor at the Instrumentation and Control Engineering Department of NIT Tiruchirappalli. He has published around 20 papers, international journals, and conference publications of international repute. He has 4 patents granted to his credit. His areas of interest are scanning microscopy, dynamic modeling, control systems, optical motion measurement, micro electromechanical systems, that is MEMS, nanometrology, and free space optical communication. So once again, it gives me great pleasure to welcome all the panelists for the program and also the participants. Over to Mr. Sudeep. Thank you.
Hi, now I request our first panelist to please start your presentation and our delivery.
Dr. Kritika, you can take over the things and proceed.
Yeah, sir, thank you so much for the introduction. Sir, I think I have a problem with my camera. Is my camera open on?
Dr. Kritika, you are connected from 2 devices. That is why there is an echo. You have to disconnect from one device.
Just a minute. Actually, I joined through the WhatsApp link.
There is another. Now there is another device you are joined to.
No, but Sir, is it fine?
Yeah, now you're muted. And one more thing is available in the Zoom.
Okay, now am I audible, sir?
Yes.
Okay, then I'll proceed.
You have to share your PowerPoint here. Please share it.
Sir, is my screen visible?
Ma'am,
It is visible.
it is echoing. You have to disconnect from one device.
Sir, sorry, I'm not able to.
You have to disconnect from one of the devices. You have connected through two devices.
No, sir. Actually, I have connected through my desktop alone.
You are connected.
Only through my desktop.
Another device is showing. There's two devices showing, ma'am. You may log out and log in once again.
So, mobile la first try பண்ணேன். எங்க பாருங்க, join meeting தான் காட்டுது. Silent. Sir, now.
No, ma'am. There it is always showing two names. One is Venkata Kritiga, another Dr. M. Venkata Kritiga, Professor E. So you have to disconnect from one of the device in the room.
Just a
When
minute.
you
Hello.
yes, now you start.
Now is it
Now.
okay?
Yes, now it is over. Okay.
But this is as a participant system.
இதுல இருந்தும் leave பண்ணிட்டோம். என்ன சொன்னார்னா நான் பேசினதுக்கு அப்புறமே பேசிட்டு leave பண்ணிட்டேன். Sir, now am I audible?
Yes, ma'am.
Yeah, okay. Sorry for the inconvenience.
No, no.
So my presentation is visible, sir?
To make it full screen.
Yeah. Okay. So thank you so much for the introduction. Sir, is my voice audible? Is it very feeble? Hello?
Yes, we can hear you, ma'am.
Okay, sir. Thank you.
We can hear you very clear, loud and clear.
Okay, thank you so much. So thank you for the introduction, and I regret the inconvenience incurred. I think I joined through two windows in the same system. So fine. So now coming to the webinar. So being the first speaker, I would just try to maintain the time given to me as 20 minutes because the next speaker has to leave a bit early. So the topic for today's discussion here is rise of cyber physical systems. And see the presenters here are from three different domains. So what I have chosen for today's presentation is I'm going to talk something on what cyber physical systems are doing with power systems. So I'm basically a power system person, and power systems today has got a lot of changes, and there has been a paradigm shift from the way in which we just design the system, we operate the system, and what is expected as the service from the power sector today. So there has been a lot of changes, and almost all these changes are somewhere due to these cyber physical systems. So I feel this is a very need of the hour to talk about this topic, especially in power systems. And thank you for the opportunity for sharing these views at this time, because everyone is now working on smart grids and microgrids, where knowingly or unknowingly we are already in usage with this cyber physical systems. So being the first speaker, I just use hardly 1 or 2 slides to just show what exactly is this cyber physical systems. So in an out, I can say in an outset, so we can call this cyber physical systems as a holistic view, which actually which is a composition of computers and networks, and which are capable of monitoring the physical process of, say, for that matter, any industry, not necessarily be manufacturing sector, for a particular process. And if you take this cyber physical systems, there are basically 3 phases which we have to address. So the very first one is identification phase. So where a unique identification has been made for most of the components of all these industries which are into this cyber physical systems. So this RFID is not a new concept for us. We have been using this RFID for a long period, but I can take this RFID even as an example for this identification phase of the cyber physical systems. The next part is very interesting. Actually, it is integration of many sensors and actuators. So earlier, people would have thought of what is the role of these sensors and actuators in a power sector. But now the scenario has completely changed. So we are slowly shifting, or I can say we are slowly replacing our meters, which were analog long back, and then gradually which were transformed to digital meters. And now we are just going for another shift, where we are trying to replace almost all our meters with our sensors and actuators. And power sector is no way an exemption. So almost all the meters are replaced with sensors, in the sense these sensors are now becoming Wi-Fi compatible. So once my sensors have become Wi-Fi compatible, then it's very easy for me to transfer this data into a cloud, or I can say into an internet, or wherever I want to capture the data. So if I stop here, then it might be a part of, say, a data management system, because I'm just collecting data and then I'm just managing a database. But this process doesn't stop there, because these sensors are mainly used to sense the changes in the environment. So when it comes to power system, it deals with current sensors and voltage sensors. And every small change in the entire system, so be it a small change in the load, or we call it demand, or a small change in the generation, or a small change in the operating point, right? So need not be a stable or unstable operating point. So that is not our point of analysis now. Whatever may be a change. So this change can be a stable change, or it can be a point where the system may enter into an unstable operating point. We don't know. But all these changes are subject to measurements. And these measurements are now taking a new shape because of these sensors and actuators. So what happens exactly here is, there can be some movement-based, or I can say there can be some slider-based measuring units, which were a very long back, which were in practice. But now we are just gradually shifting to these sensors. And once these sensors taking the positions of meters. And if they are Wi-Fi compatible, as I told, the next important challenge comes into picture in power systems is the capability to communicate this information to a particular cloud. And after communicating this, we have a database and all the control, methodologies or all the control strategies can be implemented, and the loop closes with the help of the actuators. So this is I can say this is the heart of the complete cyber physical systems, which are called CPS. So people call it by short name as CPS. And this sensors and actuators integration is going to play a very major role in the entire cyber physical system applications in power systems. So the next phase is, see how to develop these sensors and actuators. Because when it comes to power systems, I cannot use all the sensors. I have Dr. Sriram here, who is from instrumentation department. So they are doing a lot of research in sensors. They are doing a lot of research in MEMS, and they are going to nanotechnology and all that stuff. But for power systems, these will not be suitable because we operate with very high voltage and very high current applications. So there comes the next challenge of development of these sensors, which are also capable of being compatible with Wi-Fi and to store and analyze the data. So this is a very, very important phase, I would say, in order to go in hand with the integration of the sensors as far as power system approach or power system power industry is concerned, right? So these three are the major phases of cyber physical systems, not only in power system area, but in any domain. But I'm trying to correlate each of this with respect to power system domain. So now this gives an overall picture about what exactly this cyber physical system is. So if you look at the explanation here, the cyber physical system is actually a system of collaborating many computational elements which can control the real physical entities. So we have not changed any physical entity here. The physical systems are still existing, and still in power systems, though a lot of research is going on, in many places, these physical entities are quite often the conventional systems. So now what happens to this conventional systems are, we are not replacing them, but the way in which we acquire data from these physical entities. Say, for example, three-phase alternator has not changed for years together, right? So the same size, the same principle of operation, the same location, it continues in a hydropower station or in any power generation station. But the way in which I measure the current, the voltage, be it the dynamic parameters of the shaft. So whatever may be the measurements, which I was measuring using different measurement devices earlier, is now taking a different shape where I'm trying to use different elements, right, for measuring, which are capable of involving themselves in computation as well communication. So that is where this CPS or physical and engineered systems we say, because they are capable of monitoring, they are capable of computing some parameters, they are capable of involving themselves in control operation, and finally with communication protocols, so that these currents and voltages which are measured from the heavy physical entities are continuously monitored and continuously updated in the cloud. So for further analysis, we can just, our job is made easy that these data can be used for any further computation and to dictate, right? I would say to dictate the controllers whether they can continue in the same operating conditions or they need to change the operating condition. So it is like a merging of computation and communication with physical systems, or I would say physical entities. And this is what exactly is cyber physical systems. So they are not new. It's actually a myth to believe still that cyber physical systems have not been in place. They are already in place, but now we are just bringing them everything under one umbrella called cyber physical systems, which have already, resulted in development of smart grid projects, and some pilot projects are already being launched and they are in practice. So this cyber physical system, in a simple way to define, I would say, they are actually the computational elements which are capable of communicating with the existing physical systems. So this is what called cyber physical systems. And of course, this cyber physical systems, they form a very integrated part of this IoT. Because, see, as I told, we are transforming from the conventional analog and digital meters to sensors, but we are not stopping there. The sensors are appreciable if they are, capable of Wi-Fi compatible. So why do I need this Wi-Fi compatibility? If you see, they should be capable of communicating, right? They should be capable of communicating with each other, that is mission-to-mission communication. As well, they should be capable of communicating with human beings, and they should be able to communicate with the cloud or the database management system where these data are being stored. So if we stop there, it ends up like a database management, that is DBMS, whereas the next step over there is certain computations and certain algorithms are being implemented in order to solve any problem. So this problem is, as per our definition, it can be a demand side management, or it can be a energy routing. I will be addressing this energy routing in the upcoming slides. So I can address energy routing as a problem. And in all this, there are lots of computations. And as an end of this computations, we need to take some decision. So automatically a decision making is also happening here. And finally, the decision which is made out of these computations have to be communicated where the closed loop ends, right? So this is what actually the role of this CPS. So I would say CPS is actually a part and parcel of IoT. And when it comes to power systems, we call it Internet of Energy. So this is what the trend of today. We call it Internet of Energy because we have started to pool the energy wherever it is available. And we have started to draw the energy wherever it is energy thirst, right? And so I would say when it comes to power industry, this Internet of Energy is a part of Internet of Services, right? Because if you see the second point, it's a customer's gateway to the manufacturer. Now, if you look at the scenario, we prefer customer-centric, or I would say customer-oriented benefits are being appreciated. So there are lots of, mobile applications and web portals being developed in order to improvise the power quality. So at the end of the day, the customer's satisfaction is also nowadays considered as a part of all these algorithms. So I would say this Internet of Energy is well a part of Internet of Services. So this is where the system becomes smart because of this cyber physical systems. Any industry can become smart, where we just help to assist people as well missions, so that we are just in a position of connecting the real world and the virtual world. So that is what actually made possible by the cyber physical systems. So this is what a very crisp way of defining cyber physical systems. And let me skip off this. So now this is a very crux slide, which shows what exactly is a cyber physical power system. So if you look at this upper part of the diagram or a picture, so this is the physical system, which is a very famous bulk power system. So this is the convention that we generate somewhere, we transmit, we distribute, and finally we utilize the energy. And already before this cyber physical systems have come into place, there are lots and lots of power system control operations happening. So sometimes we convert AC to DC, transmit in DC and convert back to AC. So the famous HVDC systems are in place. And FATs are nothing but we don't convert AC to DC, but we just have flexible AC transmission systems. So that's what abbreviated as FATs. And these are the controls at the generation side, that is automatic voltage regulator. This is exciter, this is power system stabilizer. So there are lots and lots of conventional control units which are dedicated for generation side, so particularly generation stations. And when it comes to utilization, even though the supplier or the power provider is not having a 100% control over the load, there is a possibility to extend certain controls. Say, for example, if there is a voltage drop, which can be considered as a brownout or a blackout is anticipated, then immediately there can be a control action in the form of load shedding, so that at least some sensitive loads will be protected and some sensitive areas can be protected. So let me not go much in detail into it because this is a very conventional, traditional bulk power systems. Now coming to the lower part, if you look at, so this is the complete cyber system where you can have a wired communication, you can have a wireless communication, you can have analog and digital measurement units, right? And there are some computational components. So you have some finite state machines, then you have automatic computational units, and you have centralized control systems, everything in place. But today, what have we done in this area is, we have very judicially merged, or I would say this cyber system has become a part and parcel of the entire physical power system. So the power system is now no more going to carry only the power signals. There are lots and lots of communication signals which are coming into picture, where the communication signals are inclusive of, say, control signals, to some extent, some computation signals, right? And some measurement signals as well, right? So this is what exactly happening today in the power system. There is a very good judicial interface which helps this integration of cyber system into the physical power system. And that is why we call this as a hybrid system. And there are lots and lots of interactions between the consumer and the service provider, who is nothing but the Power Grid Corporation or the TangentCo or TransJetCo, whatever we call it. So through this cyber system, we are having this communication. So this cyber systems, they are involving both hardware and software packages, which are going to behave as interface. And when we talk about this cyber physical systems, of course, there is always a threat in the form of cyber attack. Earlier, we had only physical attack in the form of a fault or in the form of, electricity theft, which may lead to collapse. But now there is another threat, which is nothing but cyber attack. And if you look at this, cyber attack is possible in this interface, as well cyber attack is possible in the cyber system itself, right? So as a result of this, today's power system has become entirely different in its structure. So if you look at here, still we have the conventional generation stations. We have renewable and non-renewable resources. But the radial distribution system has now slowly started to get converted into a mesh system. So if you look at here, this black dark lines. So here we have dark lines and here we have dark lines. They are meant for power flow. Whereas these dotted lines, red color dotted lines, are meant for information flow. And this green color is for interface, or I can say connectivity. So if you look at here, you see the residential user is still the same, but the way in which the residential user is drawing power or energy from the existing system has completely changed. So now, wherever possible, you can generate and you can pool the energy into a particular mesh system. And if you look at the loads, this EVs and the other electronic gadgets which we are using in our day-to-day life are involved in charging process. So where knowingly or unknowingly, we are involving more of this power electronic based and digital based loads. So what happens here is there are more of non-linearities in the loads, right? There are more of non-linearity in the loads, and that is why this requires a lot of attention nowadays, because there are a lot of data communication happening. And because of data communication, we have already gone into interfacing of analog and digital electronic units into the power systems. And these are low power applications. So what happens here is isolation becomes a very, very critical issue. And the other major, a change, or I can say a modern type of load is nothing but electric vehicles, where we have started to use these electric vehicles as a storage as well the loads. So my complete power system has taken a completely different structure nowadays, which has this data center as a part and parcel of the entire power system. So earlier we used to have the regional distribution units or regional load dispatch centers, where we are worried only about dispatching the load as per the requirements of the increase in demand. But now, apart from that, there have been a lot of data center and data control units also coming into picture. So this also involves communication signal and information flow control. And hence, the today's power system is now almost looking something like this. It's having a good proportion of power flow signals as well information flow signals. So this is another way to exactly show the impact of CPS, that is cyber physical systems. So earlier, this is my physical power grid. So the first thing what we used to test is the state of the system. There are many states, like say, is it an emergency state or is it a stable state? So likewise, we have certain states in power system. So first thing what we have to sense is what is the state at which the system is currently operating. So earlier we were using some estimation algorithms and estimators, but now we are going into sensors. So if you look at here, this blue color is the impact of cyber physical systems. But earlier these sensors use real-time computations using computational units. They were all not new. They are here in the system for years together. And a decision making is there, a part of it. So based on the decision making, the control system takes action in order to have some control strategy in order to avoid the system entering into an emergency state. But now what has happened, if you see, the communication network has become a center point of focus. So the power grid can have a direct communication with the network. The sensors can have a direct communication with the network. The computation units can have a direct communication, and control systems even. So what happens here is all these communication signal flows have become bidirectional, right? So this is what the major paradigm development, I would say, because earlier it was in one direction. If you see this arrow, there is only one direction. So the signal flow is going to be in one way. But now it has become a two-way communication. So the communication network is capable of sensing as well giving some commands, right? So to give a clearer picture, this is another representation of cyber physical power systems. So what happens here is the electricity market, right, is also now coming into picture. So I'm not sure whether you're aware of the concept of dynamic pricing. See, in Tamil Nadu, still we have some slabs, and the rate of electricity is going to be based on the electricity slab. That is, domestic consumers have different slabs and commercial consumers have different slabs. But we do not have time-based rate, right? So in Bangalore, they have already installed time of usage tariff. That is, based on the time of usage, your rate of 1 unit of electricity is going to change. So what is this is, if you are consuming more power during the peak demand time, then you will be charged more. Whereas if you are consuming more during off-peak times, then you'll be charged less. This is one way of fixing the tariff. The other way of fixing the tariff is the power industry is no more going to be a monopoly, because till now in India, all the private sectors are doing business with the power grid. They are selling whatever they generate. And being a consumer, we are just doing business only with the power grid, or I can say based on the state, we have some different abbreviations. But the new policy is going to be like, we are going to have an open market where many private players will also be having their own packages. Say, for example, like how we have multiple service providers for mobile. So we have, Reliance or, Jio, Airtel, BSNL, everyone, they just say their packages, and whichever is suitable for a consumer, we are just going with that particular network. Now, a similar system is yet to start in a near future. So the consumer will be having multiple options. You may have Tata Power, you may have Reliance Power, you may have Adani Power, you may have Power Grid as well. So what happens now is they have their own packages and they have their own prices. And this price may vary from time to time. Say for next 2 hours, everyone may have some tariff. And after that, say some 12 to 1 o'clock, each one may fix some pricing. And 1 to 3 o'clock, they may change the pricing. So this is the height of the dynamism in the electricity market price fixation. So that is why I'm just putting a component here as electricity market. So these are the 2 ways in which the electricity market is also going to now become dependent upon this cyber physical systems, where without this communication, it is not possible for a consumer to know what is going to be the price of one unit, which is given by Tata Power or which is given by the Tangentco, or what's going to be the price for the next 1 hour. Without communication and without this CPS systems, it is not possible for us to get to know. And there are a lot of work going on. And I have taken one small case study just to show you. Already in Kurnool district, which is actually located in Andhra Pradesh, but it is very close to Bangalore. So they have gone for a pilot project where dynamic pricing is already in place. If I'm right, it's Reliance Power and Government of India have gone for a collaboration. So they have solar, they have diesel generator set, and they have grid supply. So based on from where you are getting the energy, your price changes, or in other words, vice versa is also true. So you can decide based on your requirement, how much you can offer or how much you can afford for the next 2 hours or 3 hours. You can choose from whom you want to get the electricity. So it depends upon your lifestyle. So maybe if you are a working person, you are going to lock your home and go out for office, then you need not worry about power cuts or you need not worry about power quality. Sometimes you need not have any requirement for electricity consumption at all. So you can just cut off the supply and you can say, I'm not going to consume anything from any of these service providers. But on the other hand, if you have any sensitive loads being on, then you should not mind paying more. So from whoever you get a good quality, then you will have to stick on to that. So this is already being tested and the pilot project is in place. And sooner, every state is going to adopt to this, where again, this cyber physical systems are going to play a major role. And lastly, this relay, which is already a conventional system, has now become smart relays. So here also what happens is the relays are ready to take their own decisions based on the operating condition, whether it is a cyber attack or it is a physical fault. The relays are capable of sensing and taking their own decision. So this is the crux of cyber physical systems in power systems. And I think this is the last one to explain you. So these are all the scenarios which are already in place. And people have gone with the real-time testbed application. So you can go with a mitigation mode will be there, but this needs training and education, which is already in place. This is just a diagram to show how to test and how to develop the research area, because this is power system real-time simulator. We are already known about it. And this is going to be the communication real-time simulation. So this is just a small case study. There's nothing much to discuss in it. There is an European project which is called Cosmic. So here already they have gone into the negotiation and exchange of energy from an individual based on the benefits, right? So it is completely a deregulated energy market, which they have already gone into, commissioning is being done. And here what happens is we have a terminology called prosumers. So we are no more purely consumers. If you have a rooftop solar or if you are generating something, if you are producing electricity as well consuming, then you are called prosumers. So here what happens is these prosumers are involved in different kinds of agreement. As I said, dynamic pricing is one of that. And you become active players in this case. Sorry, there's a spelling mistake. So you become active players in this case. You can make use of the electricity. If you have an electric vehicle, you can use the electric vehicle as a storage. And the operation of your electric vehicle, either as a load or as a storage, is also now becoming dynamic. So this is taken from a conference publication and it is practically implemented. So here they are going for a remote control and they do have Genco, and then there is a cloud for communication management. And these electric cars are also dynamically connected and disconnected. So when you are parked, it can behave as storage. If not, it can just act as a charging unit where it is considered as a load. So I'll just stop here. And this is just one example. Siemens are already into it because at the end of the day, if you see CPS, it involves digitalization, automation, and electrification. So this is already done. And this, whatever I have discussed now, is just put into one slide almost. If you look at here, energy management system is combined with all this MES and CRM. And this is, if you see, there are specific functions. So how to operate with daylight and all that stuff. And there are some routing algorithms also, because I should know from where I can, how to route to a particular service provider. And human intention with feedback through smartphones or wearable devices are also here. So this gives an elaborate operations. So I can share this PowerPoint. Due to time constraint, I am trying to wind it up. So here, this is what I said. There is an energy router and a storage system. And this is a net zero energy building. So end of the day, we want to make a net zero energy building. And I'm happy to say or share the news that in NIT, one hostel is being made as a net zero energy building with the help of some alumni and some other private supporters. We have made an energy net zero energy building, and it's commissioned and almost they have achieved net zero and they are maintaining it now. So everywhere we have this cyber physical system, and my main intention or my main motive of today's content is it has been named in a different tab, but all these smart systems which are in every aspect and every avenue today is a part and parcel of cyber physical system. So thank you for your kind, listening. So now I'll invite Mr. Bala because he has some, a personal commitment, so he has to leave fast. So maybe after his presentation is done, we can have a small discussion on his, and then we can proceed with Dr. Sriram's presentation. Mr. Bala, over to you.
Yeah. Good morning, everyone. Thanks, Institute of Engineers, for this opportunity. And I want to thanks to NIT and Dr. Venkatakarthika and Dr. Sriram for inviting me for this webinar. Am I audible? Yeah, okay, thank you. Okay, so I want to give you some details about me. I'm from South India. I'm from actually from Trichy. I came to US in 99, and I started my first company in 2001 as a founder employee, and I exited in 2013. So that is an opportunity which I started working on technology and IoT. And when Steve Jobs released his iPhone, I entered into the iPhone market. So under my leadership, we have done more than 60 plus mobile apps. So I can share you a couple of samples here. And apart from that, let me give you a background about me and the company. So let me share my screen. Share. Okay. It's shareable here. You guys are seeing my screen, am I right? Thank you. So this is about my company and myself. Let me move this. So basically, this is the company. It's called Datanetic Solutions Inc. And I'm the co-founder and the CEO. And I'm also as a board member in Pepperdine Grazia Business School, which is in Los Angeles. I'm in Los Angeles, basically. And also, I'm well connected, and I'm a member with United Way, which is one of the biggest nonprofit in US, and also CASA and San Diego Blood Bank. We do a lot of blood donations here, and also as a technical board member with Joyful Child Foundation. And I'm a very active part in the District Export Council because we develop softwares not only for US and Canadian markets, we also exports to Australia and in European Union and other parts. And just for your information, we have a center of excellence in Irvine in California, as well as in Chennai. That's where we do majority of our work. Coming back about the company, and see here, I want to show you whatever Dr. Kritika shared with you. It's more on the academic side, and what I want to share, or what Dr. Sriram might be sharing you on the academic, and he connects with industry. But
Bala, you're muted. Hello?
Bala, can you please unmute yourself?
okay, how about now?
Yeah, now you're on.
Oh, sorry, something in my microphone happened. So coming back to my case studies. Currently, we are working on software development, as we do the entire 360 degree of software development, 360 degree of software development. In this, we also work on application development, cybersecurity, and IT services like information technology services. And Microsoft Dynamics is a ERP side, and Salesforce on the CRM side. And both in Microsoft Dynamics also we have ERP and Salesforce. So these are the things what we are working with our clients across the globe. So in this one, in 2004 itself, we developed an application for NASA. NASA in Mountain View. Mountain View is in Northern California, which is next to Stanford. And we developed an application which something like connecting with sensors and actuators, helping the power grid in the solar the power grid, which is in the space station, where power from the power grid, and how that power is dissipated, which for the each and every module, or they call it as a capsule in the space station. So something we did it in the time in 2004 itself. And at the time, we don't even know we are working for NASA, because we got as a subcontracting. Because NASA doesn't work with the companies directly. They work with only big companies, with something like Raytheon or Northrop Grumman, and big corporates. But as a startup company at the time, they gave us a subcontract, and we developed that application in Flash. I think you might have heard about Flash. Flash has been acquired by Macromedia. Sorry, that is developed by Macromedia, and Macromedia was acquired by Adobe now. So we developed that application. And after that, one of the very good application I can share. This is one of my client. I'm just sharing this. So taking out. Okay. Okay. Is viewable? Can you guys see a screen called Enventure? Dr. Shriram, can you guys see the screen here?
Yeah,
Yeah,
it's
Okay.
visible.
It's visible. Okay. So in this one, this is a oil drilling machinery. Okay. We are supporting this client. And so this oil drilling goes to 2000 meters or 3000 meters. And actually, when it goes down deep into the earth or in the well, they want to bulge, they want to expand the oil rig in some areas where they want to have the force of oil which is coming out, it will block because of air locking and other things. So they do a bulging like how they do a heart and heart in the artery where they do the balloon catheter or something. What they do, the physicians, what they do similar to that, they do it in 2000 meters down. So this is something which we are connecting. See, this is the client or one of my client, they are working on this. But how we are supporting them is on the technology side. And we are helping them to make sure their applications are running good. And in our, we are using an Azure-based server. That Azure-based server, it connects to their sensor. That's what I'm trying to help you explain to the audience here, which connects with the technology with the sensor. Okay, so for example, this is the mission. This is the system which I want to share here. I don't know whether it is. So this goes inside the air. So in this one, the well they are showing in there will be airlock, which the entire system, the pipe which is going 2000 feet, 2000 meters down, it expands on certain stage where they need to expand, and then they will remove the airlock. So that is the system which I want to share with you. And the other one, which I have a non-disclosure, which I cannot show the client, but I can able to explain you guys about the system. We developed a wearable application, which that wearable we able to take initially. The client came to us to develop a wearable app with Samsung wearables, Samsung watches, only for the medication alerts for old homes across US and Canada. When we started the application, the client came to us, can we expand this RFP or the scope towards fall detection and geolocation? So the geolocation is easy to do with the wearables. I think you guys know that. But fall detection is very, very difficult. Okay. In this fall detection, we started with the Watch 2, the Samsung Watch 2. Now there is a Samsung Watch 6 that's the latest now. And even in Watch 2 and Watch 3, we started working on the heart rate, and slowly Samsung developed blood pressure, and then in Watch 4, Watch 5, they standardized the blood pressure monitoring, and we can also check the heart rate. And now in Watch 6, we developed the AA application. In the AA application, it connects with the G-force and blood pressure and heart rate. And we created an algorithm. That algorithm, it enables when there is a fall is happen, if a person fall, and if he's 80 years old or 90 years old, he cannot get up. I think you know the scenario. Okay. So in US and Canada, in a separate house or they live remotely, and if they have a fall, it's very serious for them. Okay, there won't be any to help them and to see whether they are okay or not. So the system what we developed, it alarms. It says that, hey, John, or it says the name, because everything can be programmed here, and it will ask, hey, John, are you okay? And if John is not responding in 15 seconds, it will the command center which connects with the watch. It calls the command center, and someone will be calling John. They'll be asking them, "Are you okay?" Or if he's not responding in another 15 seconds, they will dispatch a ambulance to the place wherever John is located. Okay, or wherever he is. Okay, that type of application, what we connected with the IoT, that is the watch, and with the command center with a Azure based application. Actually, it's a AWS based application, and we routed everything to in a mobile app. So that's a sample which I want to share here. Since I have a non-disclosure with the client, I cannot show the client, as well as I cannot show the product also. But we started working with them for last four plus years, and now the product was successful, and we have released around 600 plus watches to the it's a beta release, so we are going to have a gold release for 7,000 watches now. So that's something which I want to share. Apart from that, one of the main thing what we do at the cybersecurity side, we have a full-fledged CISO. CISO means Chief Information Security Officer, who takes care of all the cybersecurity alerts and applications to our clients, and normally within our company as well as with the clients. So to give a brief about the other side, uh, we are almost 180 employees now. So we deputed almost 30 plus on the cybersecurity and cyber alerts, and so the webinar which I am very much interested in here to explain those things, and which connects with the industry standards. That's the reason when Dr. Venkata and Dr. Shriram were asking about are you interested to do this, I said yes, we can able to share some industry challenges and what we are achieving in the day-to-day as a company. So that's something I want to share. So since I'm in a couple of other areas which we have non-disclosure, we cannot share those information. But if you guys are interested, I'm available online. You can send me an email, and you can ask me some questions, which we have answers, but we need to be very, very precise to the client that whether the information can be shared outside. Okay. So thank you so much for the invitation, and thank you so much for the opportunity.
Thank you. Thank you so much, Bala. Actually, there is
Thank you.
one personal question, addressed to
Sure.
you.
Okay.
It says anonymous attendee, but Mr. Bala, practical applications of IoT and computer technologies in cyber physical systems. So they just want to know few practical applications of IoT in CPS.
In CPS, okay. I think most of the things I've shared is all practical things only. Uh, uh, Another application, see, the wearables is a 100% practical, which connects with sensors, and it connects with the cloud environment, and the cloud connects with the sensor in the watch, and that's how it all the application has been used. Day-to-day operation. Okay, another example I can say, we developed for a ECG monitoring system, a mobile ECG monitoring system, where they keep it will be like a business card size. I'm sure everyone knows a business card size. This is a business card size, a small, which I think you guys can see it. So there will be they keep the monitor here in the heart area, and this monitor is being connected to a mobile app, as well as it connects to the cloud system where the sensor and actuators, whatever Dr. Venkatakrithika explained, it is all happening with this mobile application. That also we developed 2 years back, and it is under USDA approval. So even I cannot relieve the client name here because of confidentiality. So most of the things, whatever the technology industry, whatever the people are doing now, cybersecurity connected with the sensors and other things, it's all helping the common day-to-day activities for humans, and even it used in biotechnology industry, biomedical, as well as all the other various industries now. Did I answer your question?
Yeah, sure.
Okay. Thank you. Thank you, everyone.
Yeah, thank you. Thank you so much, Bala. So since Mr. Bala needs to leave, if there are any questions from his presentation, we can have it now, so that the questions from my presentation can be answered at the end of the session.
Or I'm always available online. You can Google me, Bala Sriraghavan, and you can find me in LinkedIn. You can send me a question. I can support you guys. Okay.
This NASA project has nuclear-based or solar-based systems integrated
Sol-
with sensors.
It's a solar-based systems.
There are no more questions, then shall we wind up? Dharmalingam, sir?
Yeah, Dr. Kritika, he went to the class. So on behalf of that, I can thank Dr. Bala and can proceed.
Thank you. Thank you so much.
Thank you so
Thanks,
much,
everyone.
Bala. Thank you.
Yeah, have a great day. Thank you. Bye-bye.
So now we have Dr. Sriram here, who is an assistant professor from ICE department of NIT Tirchi. So over to you, Sriram. You can start your presentation.
Hi everyone. Good morning. So a lot of things have already been told about cyber physical systems, but still many of us, we are still confused with several words, right? Like cyber physical systems, IoT, and then distributed control systems, embedded systems, and multi-agent systems, and so on. So I thought of like breaking down the individual constituents of each of these different buzzwords in my presentation. So let me start sharing my slide. Yeah, are you able to see my slide?
No.
No.
Yeah, now.
Yeah. Okay. Yeah. Yeah. So, okay, the rise of cyber physical systems, and I want to concentrate a bit more on the manufacturing side of the applications of cyber physical systems. Okay, so this is the reference document in NIST special publication framework for cyber physical systems. This is how it defines cyber physical systems. These are smart systems that include engineered interacting networks of physical and computational components. Okay, they are their nature are like highly interconnected and integrated systems, provide new functionalities to improve quality of life and enable technological advances and so on. Okay, so they have immense potential to enable innovative applications across different fields. Okay, so let us dissect that. We are looking at some smart systems. So smart systems are systems that can make certain decisions on their own. Okay, and they can also inform of those decisions to another entity which are connected to these systems. So that's why we have interacting networks of physical and computational components. So these physical components could be, for example, some set of pumps and compressors that are there in a factory, or the computational systems, which are the computers and other communication elements that we have come across. Okay, so we can have such systems. So systems are something that accepts an input and provides you an output. Okay, so that input could be either an electrical signal or mechanical signal, or it can also be just a software data that is accepted as an input to the system, and the output could be either an electrical signal, or it can be say a mechanical actuation in terms of rotating some machine, or it could be a decision that is taken by a software system. So they can be integrated into devices, buildings, means of transport. So, for example, our each of the coaches in the Vande Bharat train, they have so many sensors and actuators and interconnected systems that they can be called as a cyber physical system. And then we have production systems, which are there in our factories, medical processes, for example, even the operation theater table, which also includes, the person who is the subject who's being operated. And then the logistic processes, which also include not only the payload that is being distributed elsewhere, but also the vehicles that are used for the distribution, and also the computers with which we are making the decisions. Okay, and then you also have like coordination processes and management processes. So all of them, we have certain software that would need to be embedded with these systems, and ultimately the end applications would be, say, personalized healthcare, for example, based on your vitals, in terms of your insulin levels and BP and your heart rate. The exact dose of your insulin that would need to be injected into your body, that can be regulated. And then in case of emergencies, how exactly to coordinate the efforts, say, from different entities, for example, the fire stations or police stations and hospitals and so on. Okay, especially during emergencies like man-made floods and calamities like landslides and so on. So traffic flow management, smart manufacturing, so defense and homeland security, for example, if we have drones being sighted at the border, at a national border, so what sort of coordinated efforts that would need to be taken? So all of that can be considered as applications of a cyber physical system. So we have applications also in agriculture and aeronautics and civil infrastructure. For example, we need to know whether a bridge is healthy. In case if it is not, then what sort of control actions that would need to be taken in terms of, for example, the regulation of traffic, or in terms of certain strengthening structures that can quickly take care of having the traffic in place. In agriculture, we can have different harvesters which can coordinate with each other and come up with an overall efficient way of handling all the fruits to be plucked in an agricultural field, for example. Okay, so if we break down these cyber physical systems and look at their characteristics, we see that they are able to directly record physical data and also affect physical processes. When we say affect, you do an action, and that action has a direct consequence on the data that you are measuring, thereby resulting in a control action. Okay, and the data can interact with both the physical and the digital world, and all these entities that we are talking about, they are connected with each other and also with the global network through certain digital communication facilities, they can use globally available data and services, which means that in order to control a refinery, you don't have to be there in the within the premises of your petrochemical refinery. It can also be done through internet from elsewhere. And what is very important is the human machine interface. So it need to be multimodal as in you could be able to switch on and off your lights either through a physical mode by using physical switches, or through certain voice commands, or through some other Android application that you can use. So we need multimodal human machine interface in order to as part of the cyber physical systems. And this all can be performed if we have some collection of sensors and actuators that are integrated with physical components, and which are also connected with computers and other controllers. And this entity would need to be assigned an internet address so that it can be located in the internet, and suitable commands can be provided remotely to this entity. And also the data from whatever the sensors and actuators that we have can be accessed from elsewhere. So ultimately, the cyber physical systems, or the entities in cyber physical systems, they are self-monitoring. They are able to generate information about its own functioning. So that relates to the smartness of these entities. They can communicate with outside world, and they're also self-regulating and so autonomous. Autonomous as in they're able to function without any interference or intervention from an outside world. Okay, so let's get into how the evolution of these cyber physical systems are. We know that we are interested in a physical plant which has certain physical states that are measured using sensors and fed to a controller, and that takes certain decisions, and those decisions are implemented as action using some actuators. Okay, so in case of an airbag deployment system in a car, you have accelerometers that sense the acceleration or the sudden impact of the car, and then you have certain actuators that would deploy the airbags in front of the driver's seat. So this is an example of an embedded system where the sensing, control action, and the actuation, this is all integrated within the system itself. Okay, or embedded within the system, which is located very closely with the plant that you are interested in. In this case, it's the driver's seat, or stopping of the car. This is the plant that we are interested in. Okay, now what happens next is how we can access this information from outside. In that can be done through a human machine interface, where a human is able to access some variables from the controller, and also able to change certain set points to the controllers. For example, in case of a level control application in a storage tank, based on the need from the demand side, the human operator can set a particular set point that is variable. Okay, so this would lead to what is the automation or industrial automation, where we have this human machine interface to be given a top priority. So next is from the physical world, what all are the information that we are interested in. So we can have several of these controllers which are located elsewhere in the plant. Okay, they can talk to each other through a network. Okay, which I call here as a network fabric, and through a reliable human machine interface, this human is able to interact with several controllers simultaneously, and each controller would be implementing its own control task. So please remember that each of the control tasks would be time critical, and they would need to be completed within utilizing a certain resources, and also within so many milliseconds and so on, and also they are safety critical. Okay. So in order to implement this, we have distributed control systems or networked control systems, and many of these systems are interoperable. For example, if one of the controller fails, I can quickly have another controller take over its actions and still continue the the sensing and actuation part, so that the physical plant is safe. So this is what is being taken place in each of the flight controllers that we have. For example, the position, the yaw and orientation control in flights, you can have 3 or 4 different controllers performing the same action, okay, on your physical plant. But which controller to listen to, that is decided by a certain voting circuitry, which will vote whether the controller A or controller B or controller C or controller D, or a combination of them, which one that I need to listen to, in order to ensure a better safety and security for the physical plant, which in this case is an aircraft, and its and the position signals or the physical states that we are interested in. Okay. The control, so in the traditional automation hierarchy, we have the field level, which consists of the sensors and actuators. Above that, we have the control level, which is implemented by PLCs, and then the process control level and the plant management level, which are typically performed using some distributed control hardware. And ultimately, we have the ERP, or the enterprise resource planning, having a say on how the distributed control should take place, so that in overall the company achieves efficiency and it's able to make profits. So for example, this is how we can have a power generation company having several power plants, controlling the generation capacity at different power plants, coordinating them, so that ultimately we are able to achieve an efficient power generation over a geographical region such as a state or the country. What is like this can be done by using certain smart sensors, where we have the sensors, but they are also able to do certain computation based on the signals that they are measuring. And
Dr. Sriram?
yeah,
One minute. So can you make it bit fast so that we
yes,
have
sure.
5 minutes? Yeah.
Yeah.
Thank
So a digital twin is a software model that would use these sensor signals and the actuator signals and come up with the digital equivalent of the plant that you are interested in. And from such a digital twin, you can feed those data to an AI model in order to come up with a human-free intervention, human-free intervention of the plant that we are interested in. Okay, so Internet of Things is again several of these sensors connected to the internet through the network, and they can all talk to each other about the different physical signals that they are measuring. And again, the insights of these distributed systems is available to the human through the internet. And if we have several of these agents, so when I call an agent, I'm talking about the controller along with the sensors and actuators it is in close contact with. If there are several such agents spread geographically, but they can be connected through the internet, then we have the cyber world that is connecting through certain computation elements and also certain software models. And all these models are available for the human to interact interact with. So this slide would summarize the overall architecture of a cyber physical system, where the physical world consists of the sensors, actuators, and the physical plant, as controlled by the cyber world, where we are having several controllers and several communication elements collaborating with each other, and put together, the human has better insights over multiple agents that are geographically separated. Okay, so these are different features of the CPS. Let me skip them and show you what we are capable of in terms of like in the manufacturing sector. So we have different components that are available in the shop floor for assembly, and we have the robot. Now, if the robot knows which part to pick up based on an already trained model, okay, through the digital twin of the real system, then we can have a more 3D model driven remote assembly of parts. And a human robot collaborative assembly can be performed by sensing the human's hand position in real time, and also that of robot, and taking a collective decision on how the robot's motion should be controlled in real time. With that, we'll be able to have several of these intelligent modules being able to communicate with each other to form coalitions or communication networks, and which can be self-organized in order to carry out the system societies or the tasks that overall that we are interested in. Okay, so in such a case, we break the traditional hierarchical architecture of automation and have a swarm of several elements that are able to connect to each other and through the internet and achieve the overall set of tasks. Okay. So these are the set of questions that you would need to be interested in order to come up with the cyber physical system architecture for your particular application. So I will pass on the slides to you so that you yourself can be able to arrive at whether you need a cyber physical system for the particular application that you are interested in. If so, what are the advantages and how to arrive at the overall control architecture for the same. So these are the references that I can suggest. And yeah, I thank IEI and Dr. Dharmalingam and Sudeep sir for giving us the opportunity. Thank you.
Thank you so much, Dr. Sriram. So now we have come to the summing up, portion. So first we started with application of cyber physical systems in power systems. So I was just sharing some information on what exactly the smart grid technology is presently, happening in relation with CPS, that is cyber physical systems. And I also mentioned about the usage of communication protocols, as well the role of cyber physical systems, particularly in demand side management, as well in smart grids. So then it was followed by Mr. Bala, who gave a gist of what's happening in his own company of Datanetics, how they are applying cyber physical systems, and they are more into wearable devices. And he had shown a demo of the rig as well. And then the third presenter was Dr. Sriram. So he had given an overview of distributed control systems, multi-agents, IoT, as well CPS applications in manufacturing. And finally, he has given an interesting slide on exploring or exploration activity. So cyber physical system is nothing new, or I would say it's nothing something different. Whatever smart technologies which we are following in our own domains of research, they all can be brought under one umbrella of cyber physical systems. But what is the main difference is if you are just doing some data analysis and we are just storing it, then that cannot be coming under the category of cyber physical systems. The cyber physical system is something like there should be a sensor and it should be communication compatible. And then some decision making should also be there, which is possible through interconnection of these physical entities with the help of communication and computation. So this is what we say as cyber physical systems. So now in automation era, I can say every domain is working with cyber physical systems without the tag of the same, right? So here I already have answered few questions and I would like to answer these two questions live. So one question is based on a firewall server. So actually I would look upon this firewall. Actually, it's a good example for cyber physical system. So it is actually an interface between an internet and an intranet. So if you take NIT system as an example, we have our own server where we have some applications like email and certain other portals which are completely intranet. But this firewall actually checks the interface between this internet and intranet based on the previous history of data. So based on the every organization, you have your own history of data. So based on that, it identifies if there is a threat or something. So there is a sensing mechanism happening. Then it just compares whether it is acceptable or it is not. And then it takes a decision and then whether the information should be spam or something like that. So there is a feedback mechanism and there is a loop which gets closed. So again, very well, it can be considered as a cyber physical system. So already Mr. Balamurugan has answered it. So almost he has also told it's a programmable logic controller or distributed control system, which is equivalent to a cyber physical system. So I think I answered the question. And there is one more question specific to me, that the question says the European countries, they stop Russian oil, which impacted in heating needs and lead to failure of power systems, as it is solely dependent on diesel power plants. So in such situation, is it possible to shift to other sources suddenly without changing much in power systems? My straightaway answer is definitely no, because without changing much, it's definitely not possible to have a shift over as far as power systems is concerned. Two major points which we have to focus here is, one is protection. So when it comes to addition of different renewable energy resources, definitely this protection becomes a very, very important aspect, or I can say a very important issue to be addressed. So sometimes you may have to change the existing relays and circuit breakers. Sometimes you will have to change the setting of it. So it is not very easy to all of a sudden shift over. The next perspective is, if we go into the smartness incorporated, then there should be a communication protocol. And still there are no codes for this smart grids in full form. So it is still in the developing stage. So there are grid codes for the conventional systems, but not completely developed. It is almost in place, but not completely developed. So we need a lot of these changes, and the system should be more adaptable for all these changes. And only after incorporating these changes, then it is possible to shift. So before that, it's definitely not. So can we have more questions from the audience? I think you can have a hand raise, or you can type the question in QA session. If there are no more questions, I think we can wind up the session. So I thank Dr. Sriram for giving a wider perspective, because I restricted myself to power systems and he had given a bit of wider perspective. So thank you so much.
Thank you, ma'am.
Yeah. And sir, over to you, Mr. Sudeep. Sudeep, sir?
So, yes, ma'am. Yes.
Yes, yes. Thank you.
So this is very enlightening session. We learned a lot about cyber physical system. The term itself was explained and applications. Its applications were also elaborated in various fields. So I would like to take the opportunity to deliver a vote of thanks, the formal vote of thanks. As we conclude this enlightening webinar on the rise of cyber physical system, I would like to take a moment to express our heartfelt gratitude to all those who made this event possible. Firstly, I extend my sincere thanks to our esteemed speakers, Professor Venkata, who also played the role of our moderator from NIT Tirupalli, and her insight into the application of cyber physical system in power system have broadened our understanding of this business. I also like to thank Mr. Bala Srirahavan, who is the founder and CEO of Data Metrics Solution USA, who shared invaluable industry perspective and real-world applications of these cyber physical systems. I also express my thanks to Dr. Sriram Shankar, our Assistant Professor from Department of Instrumentation and Control Engineering at NIT Tirupalli, who have shared light in wider perspective of the application of cyber physical systems. Your expertise and dedication have really inspired us. Also, special mention goes to our coordinator, Dr. Dharmalingam, sir, who is member of our Electrical Engineering Division Board of IEI, and this webinar was possible due to his full effort. And also to Dr. N. Kumaresan, whose presence also added value to this session. Both of them did the meticulous planning and coordination to make this webinar a seamless and engaging. Your efforts are greatly appreciated, sir. To all the participants, thank you for your active involvement and thoughtful questions. Your engagement is what makes this discussion so engaging. Without your active participation, this webinar would not have been a success. Finally, let's continue to explore and innovate in the realm of cyber physical systems as we collectively strive to harness their potential for a better future. And we hope to come back again in this platform with all our experts and the participants for another session on this topic. Thank you all once again and have a wonderful day.